Code 104, maximum depth of binary tree. This is an easy question, but it's not exactly easy. It's one of the first few beginner questions like that you would come across when you're starting to do trees. Definitely not easy, right? Easy once you've understood a lot about trees, or if you've done a lot of LeetCode questions on trees. Now, the question asks for, I've drawn the example out here, I've taken it straight from LeetCode. The question asks for maximum depth, and why have I written height? Some people say depth and height interchangeably. It doesn't really matter. What does matter though is what it stands for. So if we consider the levels of the tree, so I've written it out here: 0, 1 and 2, right? These three. If we count the number of levels, it comes to 3, and 3 is the height or the depth of tree, essentially. Now, the one thing with LeetCode tree questions is some of them have to do with BFS, some of them have to do with DFS, their traversals and whatever, but some of them also do just hit one conceptual point, and it's that when you have two children, at the end of the day, most of these questions, they'll say you would want something from your right child, you would want something from your left child, and you would take those two values and you would do something with them, right? And then you would return an answer. This is just an abstract version. Don't worry if you're confused right now. I'll show how it works out in this question. But if you were like, let's say 20 here, right? You were sitting on 20. You would ask your left for some value. You would ask your right for some value. You would do something with it. Let's say like +1. You would pass it on to your parent. Your parent would consider your +1 value in there when it would ask the right child and the left child, right? And you do this until you hit the root, because that's when you're supposed to return the answer. And it's the same for majority of the questions that don't really emphasize on traversals, right? Now, what do I mean by this in this particular question? So I'll draw the example again. And also, when I say like +1 and then you add yourself by doing a +1 and then you go to your parent, we call that recursion, we call that call stacks, right? Yeah, if you've explored Fibonacci, then it's kind of like sending F4 and let's just say F3 when you're doing F5. The previous two functions would be that. I'll show how it works out. I'll actually just explain the whole thing here. Now, what did I mean by taking a left value, taking a right value? Hypothetically, okay, just think of it magically. Don't bother with the code, don't bother with the implementation right now. If I give you this tree, right, and I told you to just get the level, what is the laziest way to do it? You're the boss, okay? You're the boss. You have a bunch of workers, okay? These children are your workers, okay? They're your workers, and you're the boss. You're a lazy man and you don't want to do anything. So what is the best way to get the answer, or get like whatever you want? You make your workers work for you, right? You don't care about what they do, you just want the answer at the end. And you're kind of like that with trees. Your workers will go off, they'll do some work, they'll get you a value, let's say 1, they'll feed you that value, and you'll make a decision based on this one will also return, let's say like 2, right? Hypothetically for now, they are the answers, but hypothetically for now, this one will return 1, this one will return 2, and it's up to you to make the decision of which one to pick and add yourself to and then return an answer, right? You're kind of the big man, and then everyone else is just going to feed you values. And every time, right, at the end of the day, you are the big boss, right? You're the big boss. Some of these workers can be promoted to, let's say, managers even, right? When we do our traversals into them, they temporarily become managers. Now, what do I mean by this? So I'll just get down to the answer now. Since I've explained the analogy of going up to the top, so yeah, in height, we will ask our left child 9, okay? We'll ask it, don't worry about the code, we'll ask it, do you have any children? They will say, no, I have no children, right? They know. If you have no children, then in terms of height, we should only bother with you, right? So we'll only bother with this one singular node, right? We'll just say, okay, then just return 1 in that case. No worries. We'll do the same for 20, right? But this time 20 has children. So we'll tell 20, okay, if you do have children, how many do you have? I will say I have 1 for each side. Then we might go and ask those children, how many do you have? They would say, we have none. So could we say that 15 would repeat the same thing 9 did, right? These two can be used interchangeably. Even 15 would return 1 at the end of the day because it has nothing going for it. And 7, same thing with 9. It would just say 1 as well because it's only itself. And now here, 20 is a manager. It's a temporary manager, right? You're still the big man. The root is still the big man. But you're temporarily the manager. You have 1 from your left, you have 1 from your right. Okay, so you haven't done much. The workers haven't done much. So you have to make a decision now. You have been fed the inputs, you have to make a decision because you're the boss. And you have to relay it back to me, the big boss, okay? So now we'll say 1 and 1. 20 is the manager. We'll pick 1. There's really no choice to make. You'll just pick 1 at the end of the day. You'll pick either one. And what you will do is you will add yourself because we are considering heights, right? We'll add ourselves because when you do take down this path, right, there is 1 node in between you and this in between 3 and you, right? So we'll just add 1 to whatever answer we got from our left and our right. So we would say 20 would end up with a value of 2. And it would be the same thing for number 3, the big boss. The big boss would say, I have 1, I have 2 coming from my children. And I want to find the maximum, right? So of course I would pick 2 over 1, right? And I'll do the same thing 1 because I obviously have to consider myself, right? Like the same thing for 20. You have to consider yourself and then you'll pass it on because you're the manager, you're not the boss. But the boss will say, okay, I've done this and now I'll just return the final verdict. There's no more processing. The boss said it's 3, so it's 3. That's the answer. That's it, nothing more, right? And if we wrote this out in code, it would be the exact same. So if we just write if not root return 0. Now this is what they call the base case, right? This is when we hit 7, we will for some time go into these empty nodes and we'll come out of them saying 0 and 0 because there's nothing to process. But we will now just do, we'll say our height that we're getting, the height that we have right now is the maximum of self dot max depth. I won't write out the full function after this, but I'll just write it out like this and then call the same function over here, and this time pass in your root dot right. You want to do a maximum in between those two, so you'll ask your left, it will return 1, right, like I did. This will return 2, you will store 2 because at the end of the day you will only keep max, and you will just return 1 plus whatever your height was. Now what do I mean? Because I did say, like, I'll explain what I meant by doing call stacks and recursions. So if we run through this code, okay, I would say LeetCode is given a pretty not that good of an example. It's pretty simple, but I guess it's helpful for just writing it out. So when we're at 3, we're the boss, we're lazy, we won't do anything, we'll delegate our job to 9, we'll delegate our job to 20. 9 becomes a manager for some time, 20 becomes a manager for some time. We, the big boss, we will wait on the final verdict. We won't do anything. We're disconnected right now. We're disconnected, right? 9 and 20 will go off and do some work for us. 9 will say, okay, get my left, get my right, and guess what, they'll come out to 0 0 because we will go into those nodes, they're empty, and we'll hit the base case. If not root, that means they're none, or no as they say. We will hit 0, we'll come back with a 0, we'll use these two values, we'll figure out the maximum in between them, 0 and 0. There's really no choice, it will just be 0. But before we pass it on to the boss, we will add 1, right? Before we go back, we will say plus 1. We consider ourselves, right? Now same thing for 20. 20 will, since it's the manager, it will technically still just go to 15, it will go to 7. 7 and 15 become managers, right? For a temporary amount of time, they'll become managers. They will ask their left, they will ask their right. It will come to 0, it will come to 0. We'll add ourselves 1. Same thing for 7, right? And once you get back from here, they've reported to their boss, right? The managers have their own boss. We are the big boss, right? So we'll return back to our manager and we'll go to 20. 20 will be like, okay, now I have 1, I'll figure out the max in them. There's really no choice as well, so we'll just go with 1. But you'll add 1 before you leave, and you'll pass this on to your boss. So now your boss is getting 2 from here, and he's getting 1 from here. So your boss, all he has to do now is just go max 2 of 1. He picks 2, he adds 1, returns, and he gives the verdict, and it's over. That's literally it. So that's what building a call stack is like. You essentially just have a bunch of workers becoming managers. They do something for you, you get some value, you process it, and you're done. That's it. You, at the end of the day, you're the boss, you'll give the final verdict, and that's it. So here's the code, right? If that's something you want to take away, then this is the code. I'll clean it up, but this is the main part of this question.